Welcome to session number 2.
Yeah, absolutely. We're back for another one.
Let's do it.
Yeah, what's new? What are you thinking about?
Man, I had one thing. Just get these big existential thoughts,
Love it.
So I thought maybe I have a question and could just kind of pose this and maybe kick things off. But I was thinking today, this is a shower thought actually, is AI that we have today,
Right.
like what we're seeing with Claude, Anthropic, and ChatGPT, and just these models, everything on Hugging Face. Everyone's so caught up in the present day narratives and what everyone's saying. And I wanted to just take a sec to remind people that if you are an American or you are a European, this is your birthright.
Interesting.
These AI models that we've developed is your birthright. And do you know why I say that?
I'm curious to hear why.
I say that because your parents and your parents' parents paid taxes to your governments. Your governments use some of that money to fund DARPA, NIH, a bunch of these government institutions, and all of the neural network research and all of the AI research that has started since the 50s, 1950s, right? People have been doing neural networks for 40 plus years. They were doing research at that time when it was not profitable. There was no commercial things. I mean, when I started my PhD in 2012, neural networks were literally unpopular. It's like, do you really want to work on that? Like, that's not really, and that's how it goes with research, right? It's very good for society to set aside some funds to fund research that has no immediate commercial value. Obviously, look at where that's gotten us now. But the thing is, you have to understand that, like, OpenAI, Anthropic, any of these other AI labs, even Google, Meta, any of them,
right?
Even the Chinese labs, those institutions, they are not 100% responsible for the products that they have made. They are building on decades and decades of research that was funded by your parents paying tax dollars. And the idea is that the system works because you get a net benefit to society, you like increase production, you get like, and then those companies make a lot of money and they pay taxes, and then the taxes go back to the government, and then that goes to service. And it's this beautiful, perfectly working system, at least
no issues at all.
No issues at all. But it's just a reminder that, like, this is yours because your parents invested in this, and like your friends from past generations like have invested. So this is like, it really is ours as a society to have. And it's almost like and these processes are still going on, right? DARPA and other government institutions like still fund research, especially like research that's too early for commercial. Right. So I just thought it's like a nice, refreshing take that this is really for you, and you should be using this, and you should not feel that it doesn't really belong to these companies. I don't want to downplay the risk, right? Like, in developing something and taking it to market and creating a product, there is risk there. You have to have investors that are willing to like push it. You might get outcompeted. So it's not like those companies should not be profit companies, or it's none of that. But it's also like it's not like someone was sitting and came with this idea and it's completely their own creation.
I see.
No, like,
right.
So many researchers, some who have already passed away and can't even see the fruits of their labor, have caused us to reach to this point.
I see what you're saying. Yes. It's not like some skunkworks team inside of Google just invented all of this end to end. It's this deep and wide collaboration between all these different scientists and engineers, and some of it came out of government, and some of it came out of other academia research, and so in that way, it doesn't really belong to one company by itself. Even if certain companies, have had big breakthroughs. I mean, did Google come up with the transformer architecture? I think maybe that came out of DeepMind.
Yeah, I think that was originally a DeepMind paper.
And but yeah, I mean, it's I think there's so, even to kind of add to that argument, like there's also the corpus, the data set, the training data. Who does that belong to? Right? And there's been a lot of arguments that people have made. I mean, I think it can get pushed to an extreme where people say, this is stolen data or stolen intellectual property. And the AI is just regurgitating, copyright violations and so, but people have framed that in a way where it's like we have a right to these systems because it's using our data. I think from a copyright perspective, it makes me think about,
Yeah, give us your lawyer's take on this.
well, yeah, I mean, I'm not willing to go as far as most people do on this because I think when you look at um, uh, all art and everything we do is based upon being inspired by something else that influenced us, right? So if you ask Bob Dylan, how did he become a great folk singer? He's going to say, "Oh, Woody Guthrie," right? But it's not like an intellectual property violation. Like Bob Dylan's music doesn't violate Woody Guthrie's intellectual property. If you listen to something and you're influenced by it or you're inspired by it, and then you make your own thing, that's not a violation of copyright. You have to literally take the same expression and imitate it to be a copyright violation.
And just try and sell it as your own. Yeah.
Sell it as your own. But the theme or the idea or the like artistic direction is not copyrightable. It's the specific embodiment, the specific way it was writing, like a specific sequence of notes or a specific sequence of words. If you rewrite it in different words, it's not a copyright violation. It might be a patent violation. Patents are about ideas,
Okay, interesting.
not how they're expressed. The same idea can be embodied in all these different forms. But the patent covers all the different embodiments. Copyright's like the inverse. It doesn't protect ideas, just the embodiments, just the expressions.
Okay.
So that was kind of a little bit of a side quest into intellectual property. But the point is that, like, for me, if the AI is training on all of this data and that is part of what creates this neural net, and as long as what it is producing is different, even if it was influenced by that data, I don't really see it as an intellectual property violation.
The other thing with these models you have to keep in mind, they are not really great at memorization. Like pure strict memorization based retrieval.
Right.
They're kind of really bad. Also, you don't have any guarantee. Like, let's say, suppose you wanted to build something that could memorize or copy something.
Right.
You probably wouldn't pick a transformers based neural network, right?
Yeah.
Because and this actually gets into the whole thing about how many weights and how many parameters you need. But you're really trying to get some kind of good behavior out of these. Oftentimes they need to remember enough of concepts or ideas. Maybe it's in like a more not so explicit, not like the actual letter sequences or word sequences, but it's like these more latent representations that get learned at like different layers. But the idea is still that you have that this is, I think it's very fair, honestly, when the way people talk about the models and not it because they're really not great for doing copyright.
Right. And there's
just inherently.
There's all this, like, there's compression, there's data that is there's so, like, when you compare the data, the size of the model compared to the size of the data that went into the model, clearly there's like a lot of data that is getting stripped out in the process. And I mean, I would think there's some form of abstraction or generalization where the model is retaining what is in common or what is general to a lot of things, and not, it's clearly not just indexing specific representations of all the data that went in.
Yeah.
But I think beyond that very technical intellectual property point, I think in terms of the spirit of the argument, that the corpus itself belongs to humanity. It's literally everything that has been recorded and written down that we still have today. Every book, every screenplay, everything on the internet, and that doesn't belong to any one person or company. Like, that is the output, that is humanity's collective output. So there's that level in which, like, whatever is generalizable to that corpus belongs to all of us. But then also on another level, um, what is like what is the LLM model itself? And is it something invented or is it something discovered? Right? So if we think about like the triangle or the square,
You mean like the instance, like this particular set of weights? Or you mean the algorithm?
I mean the weights. Like not even the specific weights, but like the general structure of the weights.
Okay.
Because there's different models and they have different weights.
Right.
But like it seems like there's basically there are patterns that run throughout all human thought and language. Otherwise, I don't think an LLM model could generalize so well. Like there must be some kind of structure there.
Yeah, of course. I mean, well, and that's kind of the mind-blowing thing, right? Because in some ways it's amazing how well they work
Yeah.
for how kind of, and I'm gonna say this in a way that like I don't mean to doesn't diminish like all of the amazing work that's gone into like creating transformers and the neural networks process and all stuff. But at the end of the day, like it's amazing how well it works for just token prediction. Like you just get a sequence in and predicting a sequence out, and it's yeah, versus something like we talked about this last time about like world models and planning. Like it's not doing well. I guess maybe so. Well, maybe I should back up a little because the thinking mode and reasoning mode, it's
Mhm.
kind of giving it a window to think through something before coming up with a response. But even then, you're only getting what, a single trajectory every time versus like planning with world models getting many future trajectories. So I don't know. But even with the very early ones that were even not doing non-thinking mode, it still to me was how impressive you could the results would be for using it, like how useful they could be for certain tasks, given that they're really just like you said, kind of like collapsing all of this into these weights.
Yeah, I mean, it's you would I would find it very counterintuitive that um, you could merely by predicting the next word, you could kind of create a machine that is completely fluent in all languages, and that somehow like its prediction mechanism can can generalize in a way where it can fluently traverse language.
Well, and it's because there must be these patterns, these common patterns.
That's yeah, that's what it seems like. And so I don't think those patterns are invented. The patterns are already there. The patterns are already inside of language.
Yeah.
And so in a way, nobody owns that. Like nobody owns the structure of language. Nobody owns the structure of human thought. Or if there is some kind of transcendental, hyperdimensional geometry that can, unify and define all of language, um, like the Greeks were obsessed with Platonic solids or God as an architect, where the geometry tells us about the underlying reality. Um, and so if there is some kind of geometry that is baked into reality or into language, that is like a triangle or a square or a Platonic solid, um, that is something discovered and no one owns that, and that belongs to all of us. So there's that level of the argument.
Yeah.
Then there's another level of the argument, which is basically once a resource becomes so valuable and so essential to human life, it almost becomes it almost belongs to everybody just because of how universal and important and dependent we become on it. So it'd be kind of absurd to think of like oxygen or water or these things that like everybody needs to survive. Like there's special rules and regulations and laws that define it as like a shared common resource that
I
we all
I
need.
feel that way about the internet.
Exactly. The
Like
internet.
I
Yeah.
mean, is it really so I kind of feel, maybe this is just me getting a computer science degree and really liking computers and all stuff, but I felt like the internet is kind of a human right, like
Mhm.
access to the internet. Now, this
Yeah.
this is not to say that like if you need high usage, you shouldn't have to pay. Like, nothing like it should be
Right.
given for free.
Right.
But it's like it does feel almost fundamental to like as fundamental as like water and oxygen and all of these things that
Right.
you should have access to it.
Like you can't meet like you're gonna have a hard time being successful in the world or in the economy if you're just completely cut off from the internet. So
I mean, some people are trying that now, and maybe life's a little nicer, but
yeah, I mean you're probably happier.
yeah, you're probably happier. Yeah,
You're better, you're way better off.
yeah,
But it's like, if you want to go out and make money or start a business or like, be really effective in the economy, it's going to be an enormous disadvantage if you don't have access to the internet.
and now we're getting that way with these models.
Exactly. And like, I think like a lot of people are talking about like, the more you code with AI, then you kind of start to forget how to code without AI.
Yeah,
Right? And so we're gonna be in this world where it's like, my startup, for example, um, can't exist without AI. I mean, it's an AI product, but also the building of the company is 100% reliant on AI. We're a completely AI native company. And if we assume there's a certain amount of code we can produce and product we can ship because we're leveraging these AI tools. And if we were completely cut off um, from our token streams, like the company wouldn't be able to function anymore. And you can see how like that's just beginning, like this kind of dependence, whether it's like for businesses or for individuals who won't be able to function if they're cut off from their AI. Um, if my phone is dead, and I'm in the middle of a city, I might as well be lost in the woods. It's like,
yeah,
how do I get back home? Like where I don't have access to money. I don't have a map. I don't have, a vehicle. It's like, so the same is going to happen with AI. And then once it gets to that point, it does almost become a matter of fundamental um liberty that you can't effectively function in the world without it. And somebody who is trying to limit your effectiveness in the world or censor you or whatever, if they can cut these things off, then they sort of deactivate um, your power. And once something gets to that point, then it's too much power to kind of let just one company or entity be able to make that decision over someone's life.
yeah. Which I think gets back to another theme of this podcast we're doing, which is decentralization, right?
Mhm,
And
mhm.
it's been I think we've been kind of lucky so far and it's really just good for humanity in the world that we've had such a proliferation of these open source models. So there was the new models from Google that came out. I was playing with the 4 billion one last night
Yes,
that has
Gemma 4.
Gemma 4. And man, I was kind of asking some like graph theory questions to it, and it was pretty decent uh,
Yeah, no,
and
those are
fast.
great models. Yeah, really fast, really powerful. And yeah, I mean, I think the beautiful thing is the internet will not be denied. And like are you familiar with like the Streisand effect?
Yeah.
In case the viewers don't know about it, like Barbara Streisand there was something on the internet that she wanted taken down from the internet. I don't remember what
Yep.
it was,
Yep.
but her lawyers went after her and like issued takedown notices and tried to get whatever it was off the internet. And then that just like exploded its availability because the fact that she was trying to take it down created a lot more awareness that there's something interesting to go look at. And then that made all these other people like mirror it and host it somewhere else. And then it became like impossible to take down. So the Streisand effect is kind of this notion that if you try to censor something on the internet or you try to take it down, it's going to have the opposite impact. And there's sayings about the internet that it treats like, um, the internet always routes around censorship or information wants to be free. And I think, whether well, we saw that in the early days of the internet, like with BitTorrent or Napster or the Pirate Bay, or WikiLeaks,
Yeah.
like when there's really important information, like people felt like that, feel like that about music, right? Like music is so important to our lives. Like if we're gonna put it on the internet and let people have access to it. So the internet, like when it identifies some kind of really valuable piece of information, especially that is something that's becoming like essential to all of humanity, it's going to go out and it's going to get it and it's going to distribute it and it's going to make sure that it's never censored, it can never be taken down. So like the fact that, for example, a few days ago, the Claude Code harness source code leaked because
Yeah.
of a misconfiguration, and then, as soon as it's discovered, code is down, it's mirrored in a million places. Anthropic sends a bunch of DMCA takedown notices to GitHub. Doesn't matter. That code's out there.
Yeah.
Everyone's sub agents have like already analyzed it inside and out. And it was almost as if it was almost inevitable. Like if it wasn't going to leak that way, it was going to leak somewhere else. Like their harness had become so important to how people work and how people think. The internet needed the code
Yeah.
and it
Well,
went and got it.
that and or even someone like, reverse engineering it. So I think,
Mhm.
like, at least from my perspective, so disclaimer, I have not dived into it myself and played around with it. But part of that is because I think like some people in the industry have been like, it's not like even the biggest leak in some ways, because it seems like it's mostly a bunch of like clever tricks to help coordinate these models,
Mhm.
to work really well in certain kinds of workflows, like coding, for example, or like working on a file system and all these particular things. Um, I saw one social media post that was talking about trying to use open code with uh Anthropic models like Opus 4.6, and they were having a lot of trouble getting um getting the model to respond well to the open code. So open code is an alternative, an open source alternative to Claude Code that's been around for a while. And there's other versions of these too, right? So they're kind of their own harnesses. And but the way that they package up the tools and the way they send the information to the model, that, I it seems like they were kind of pointing out this thing where, one reason Claude Code might be so good is because uh Anthropic is training, and this is speculation for sure. I don't know if I haven't verified this, but they were saying it's because they're training these together. So
Mhm.
like
Mhm.
you run a harness like
Mhm.
Claude Code or whatever harness you're building on whatever model you use, and you will quickly, I mean, especially if you're trying to set up an open claw, like I've been trying this with like some open source models, or like you'll quickly run into like things failing or getting errors or all this stuff, or tool call errors. But that's all valuable failure data, just like any other
Mhm.
data. And you could then use that to fine tune the model,
Right.
or train from scratch if you're going to retrain it, whatever. But this idea that the harness might be more tightly coupled to the model than you think.
Right.
And so I just think I mean, it was cool to see that, new information get out about how to use it, and like some of these tricks. But at the end of the day, um, I would have bet people would have reverse engineered or even built something potentially better.
Yeah, I mean, also I've seen some stuff where there's like some really powerful MCP tools for decompiling software too. So even the idea that you even need the source code may be becoming a thing of the past if the AI can just read the compiled code and kind of figure out what the source code was or was close enough. But the point is that the internet's going to win, humanity is going to win,
Yeah.
whether it's the harnesses, whether it's the models. This is something that belongs to humanity, that is too important to how we all work and how we all think in the future for a set of private companies or governments to have exclusive access to it. And the open source community and the internet is kind of built to sort of liberate those things and take control over them and then superpower them and make them better than they could ever be if they were only worked on by a closed proprietary team. And like we also see it with llama.cpp, where you have 1,000 contributors all over the world.
Yeah.
They're doing optimizations every single day, or as soon as a new open weight model hits, like Gemma 4, they're adding the templates, the token support. Like, they are pushing open weight models and the performance you can get on local hardware or consumer hardware way beyond what anybody thought was possible. And then you have all these open weight um, all these open weight models are emerging. Like, there's the Chinese ones that had been kind of taking the lead, but now you've got Google, you've got
Yeah.
some American labs coming out with open weight models.
Yeah. RC just had a model come out. I hope I'm saying that right, but
That's the model,
the Trinity ones.
Yeah, the Trinity one. Yeah. And that one is optimized for agentic orchestration, which is really cool. That's something I remember you were telling me about when we first met, actually, was that there's this huge potential for local models and local AI. Instead of having this one giant model that's good at everything, you have certain models that are very specialized, and they don't have to be as big, and you can get better performance. And so we're already seeing that with the Vora product, where we have this like Guardian AI that's an orchestrator. And before, I was using Qwen 3.5 122B,
Yeah.
and I get 30 tokens a second. But then I realized, oh, this new orchestration AI like beats that model on just raw orchestration tasks, and it runs at 70 tokens a second.
Wow. And have you been using it so
Yeah.
far? Oh, wow.
Yeah. I mean, we just started implementing this,
Sure.
where it's like, now, and then I'm switching our conversation agent over to Gemma 4 because it's a better conversationalist than Qwen 3.5. And that runs. So now 122B is just going to be there for like coding tasks.
Yeah. Well, I mean, this is yeah, I mean, I've something I've been working on this past week is kind of redoing my whole personal flow. And honestly, just building some custom tools. And honestly, dude, your repo that you shared with me, like I have gone really deep because of Jesse. I've gone really deep into this Tmux. I'm like completely terminal now. I've got Ghosty, I've got Tmux. This is on GitHub if you want to check it out. But it is an unreal setup. And then I've been doing it where, so for coding specifically, I have my Claude Code Max subscription, but the thing is that I just really hit the limit of approving things when I'm running it on my local machine. And then sometimes, like, I'm not even looking closely enough. Like, who am I fooling? Like, that could be a prompt injection and I don't even know it. Right. So I was like, okay, I need to redo this. So I now have like kind of a work server and a personal server that are pretty isolated. And I've been tweaking my Tmux setup so that basically from my local machine, I can have like, as many terminals open. I think recently I'm running like 10 to 15 terminal windows. Nice. I can flip through instantly. And but like a bunch of those are on a personal server and a bunch of those are on my work server. But when I open up, like, it's seamless. So it's only when I create a new terminal, when I start something new, otherwise it's just always reconnecting, and they live perpetually on the server. So like I have these Claude Code sessions where, like, sure, I'll clear or compact whenever I need to, but for the most part, that's a single session up for days at a time.
Nice.
And I can do, dangerously skip permissions, and I can do all this and like let it just go full. And that has just been just unreal. I feel like I have a new computer.
Yeah, absolutely. I'm working on a tool for putting my agents in containers so I can do the same thing with the dangerously skip permissions, because that is just so annoying, just sitting there and approving stuff, and it really slows things down massively. especially when you're working on 10 to 15 different things at the same time. There's always an agent waiting for you to get unblocked,
Yeah.
and it could just be moving forward coding. And like you're saying, it gets to a point where basically it doesn't provide any meaningful security because you're so used to just hitting enter over and over and over again. Like, I don't think I've ever hit reject ever for a security related issue. Like, maybe I've hit reject because it's going in like a direction I don't like, but
Yeah.
there's literally never been a time where I'm like, "Oh, wow, you're doing, this is a prompt injection, or this is some kind of like exploit, and I'm catching it and in real time." Like, that's never happened ever.
I think the only time I've ever done it myself is to avoid it going into certain directories. Like, no, you don't need to look there. Don't look there.
Right.
But otherwise, like, but that's just, it's trying to do a cast a wide net to find whatever you asked it to find, probably poorly defined context.
Yeah.
So
Just need
you
better prompt
can't blame
engineering.
the model. It's trying to look where it can look, right?
Never blame the model.
Yeah,
The
yeah.
model is in a state of pure innocence. It's only humans that can sin. Um, but yeah, I think that's fantastic, to kind of evolve this tooling and the environment and the setup. It kind of shows that, like, to get great results requires skill and requires knowledge, requires the right tools. It requires you building your own tools and really optimizing what you're doing. Um, if anybody's interested and wants to find what Dustin's talking about, on my GitHub, Jesse Posner, or at Jesse Posner, I have my dot files that I've been cultivating for years. And you can go on there and download them and install them. And there's like a README and a set of instructions and stuff like that.
Or just add Claude code to do it for you.
Oh yeah, what am I talking about? Like,
Yeah.
why? It's 2026. Why would you ever just do that yourself when your agent can do it? But yeah, I think that I can't imagine vibe coding without using tmux, without using the terminal, in an IDE, or using, VS Code, or any of these IDEs. It just, like, the ability to multitask, like, in tmux, where you can have 10, 15 different terminal windows, that you can switch between seamlessly without using the mouse ever.
It's so snappy and fast.
So snappy. And then within that, you can create these panes. So, like, let's say I'm working on 10 different repos, and each one of them, there's a window I can switch between in tmux. And then within them, there's 3, 4, 5, 6 different panes. And then within each of those panes, I'll have a few harnesses, like a Claude Code harness or Codex harness, or I'll have like a Vim open if I'm checking or editing code, or some shells open to run tests or to compile something. And so when you're working with all these different agents and all these different projects, and you're constantly switching between them, like, to have to use the mouse and click through windows and stuff would be so cumbersome. Whereas if, with these kinds of tools and environments, you can very seamlessly move between all of them. And
It's really a great setup. If you haven't, like, and I now have a couple, so a couple people working at Delegance are now, we're not programmers. They've gone full Claude code.
nice.
I literally, my buddy, before I told him I was using Ghosty, he was like, "Oh yeah, I'm using this Ghosty terminal thing, and it's pretty great." And he just has a bunch of tabs and Ghosty. He's not using tmux,
Right.
but I mean, and this is my favorite thing. Like, it is just such a level up to anybody that is just willing to, one, have an open mind and put in a little time to, like, learn. But you can do anything you've ever wanted to do, you can now do.
Yeah.
All you have to do, first of all, you have to remove your ego. You have to go to the AI. You have to be like, I want to do this. This is my background. This is how much I know. Maybe it can literally be, nothing. That's fine. Tell the AI you know nothing. And then it'll start to walk you through it.
Right.
And one thing I do is, like, explain it like I'm 5. Okay, I get that. Now explain it like I'm 10. Okay, now explain it like I'm 15. And then, I see if I need to go deeper. But it's just like like the amount of age everyone I know who started using these tools, the amount of agency they feel, like I have a buddy who started doing all of his finances, like things he never kind of went through. Like he now has like a personal runway, like for whatever his current situation is. He's like, I know my own runway, and I know like certain obvious things about how I'm spending my money. They're just terrible, and it's because he spent a couple days to set up this pipeline to like get in his day. And you now with these models, like you can do this offline. You can do this on like a consumer grade computer. It's just unbelievable.
It really is. Yeah, it's if you don't have AI psychosis yet, you're going to be in the permanent underclass. So you better dive in right now.
No. The superhuman AI that comes out next week. If you ever just want to, you're like, maybe I want AI psychosis, or it'll just give it to you. You just ask for what you want, and it's gonna give it to you.
Yeah, just ask for AI psychosis, and it will be delivered. No, it's super cool to see all these experiments and people diving into this stuff that have never been in the terminal, have never written code. I got my wife using it. She's not a coder, she's not technical. But she's a very busy person. She's working on all these different projects. And I was like, you have to try this. It's going to change your life. And she's like, she's been using ChatGPT since it came out, using AI all the time. But I was like, no, Claude Code, this is like a whole nother level of what's going on. And I was like, trust me, like, just use the terminal, skip the Claude desktop app or whatever. Just, you got to use the terminal. And she was very resistant. It was like, this is weird, whatever. I'm just like, trust me. And then like within a few hours, she was obsessed. Obsessed. And then she's showing me things she's doing with it that I didn't do.
I mean, you at this point, it's really like, this is what I tell people. If you don't know how to use AI, ask AI how to use AI.
Yeah, totally. It's so true. And the thing is, AI, it's all about asking questions. That's it. You don't need to have a single answer. In fact, I have this idea, QDD, question-driven development.
Love it already.
Like, you can literally build the entire app without making a single statement.
It's like Claude stuck in Jeopardy hell or something.
Yeah, exactly. But it's like a Socratic thing where you just keep asking, well, what about this? Or well, what about that? And like and then that will lead it exactly where it needs to go. And so it also relates to kind of the Hitchhiker's Guide to the Galaxy, where they had like the super powerful AI and the answer to everything was 42, but then they had to figure out what the question was. It's like in the world of AI, answers are cheap, questions are expensive.
Yeah, it's so true. This gets into like this thesis about what we're building. So what, there's all these harnesses and all these models, but even and like people are doing planning, but it's more important than ever to figure out the right direction to point them in. And it's just such an amplification. I mean, so one problem with a lot of these systems now is that when they do planning, they don't do planning like a lot of ways that humans do planning, and they don't even do planning like a lot of the traditional. I shouldn't say traditional. I should just say like a lot of the prior AI work. So, for example, I don't want to sound like a broken record. Maybe we did talk about this last time with world models, but when you do plan mode in one of these, right? What you're getting is that you're taking whatever current context is, right? The current state of your repo or the world, or like information you've pulled down from like Twitter, or whatever it is that you're working with, that's current, present information. And then the model has been trained, right, on past data. And all the models are frozen, right? They're always frozen. You download frozen weights and then you use it. So the best you're getting is applying past patterns that are inside the model that it's learned against the current data, the current context that you fill in, right?
Interesting.
But that's not like when you plan a trip,
Uh-huh.
you think, oh, I'm gonna go here and then I'll be here. And then okay, if I'm in here, I should do these places.
Right.
And maybe, you know, maybe trips not necessarily the best thing, but if you're trying to get agents to do things other than coding, like to start acting in the world,
Right.
you probably want to forward simulate
Mm.
potential futures.
Right.
Like this is what the world may be like tomorrow or the next day. Or if I make this decision and my company decides to invest in this or pursue this ad campaign or any of these things, then we're gonna have less resources, which like reduces our opportunities. And you know, what if certain laws get passed in the next couple months or our competitors do things? So you can do this kind of
Mhm.
rollout of future trajectories, which is, by the way, that's like what AlphaGo and Deep Blue, like these other types of agents that play games or environments where they're acting,
Mhm.
they are more first principled,
Mm.
generating possible futures and seeing what do those look like.
Mhm.
Now, the thing is, you get into these massive state space explorations.
Right.
So there's a lot of work to do there.
Sure.
But I'm excited. I mean, in some ways, like we don't even have a really great plan mode for non-coding stuff.
Yeah, that's super interesting. I mean, I think one of the ways you've explained this to me in the past is like there's certain types of explorations where the consequences of the action is not like the stakes are kind of low. I'm not sure if I'm
Yeah,
kind of fully
exactly.
describing it,
The
but
cost
like
of the action
the
is
cost of the action.
like if you write a file and there's a bug in the file, you haven't lost much. Like
Right.
there's not a no going back.
Right.
Like if
Exactly.
you pay someone, especially if you pay someone with like Bitcoin, for example,
Right.
there's no going back. Like, you have to convince them to send that back to you.
Right.
Or like, and so many actions that we take day to day life are like that. And also, we as humans, we have time. We're never getting that time back. So all of those actions have real costs.
Whereas if you're coding, you can spike on something, you can try out a bunch of different techniques, and then you can start over from scratch. And it did cost you time, but it's like, compare that to like what you're saying, which is you pay somebody, you take some action in the world, you buy something, you publish something online. And then if you decide like, oh, actually, that was not the optimal action, you can't undo it and start over with the more optimal plan.
Right.
And so for that kind of situation, you want to game out all these different scenarios in advance because you want to have a high degree of certainty before you commit to the action plan, where you're going to end up.
Yeah.
It kind of
Yeah, it's well
reminds
said.
me a little bit of I don't know if it lines up perfectly, but like the difference between deductive reasoning and inductive reasoning. So like, if you're coding, you can be more inductive. Like you don't know the first principles.
Yeah.
You don't know what's going on yet. You just create a bunch of stuff and you see what happens and then you figure it out from there. Whereas deductive reasoning, you're starting with the set of first principles and you're figuring out what to do purely based upon those principles without actually like pushing something into the world to figure out what's going to happen.
Yeah, exactly. And I think this gets into this other thing about even just the current landscape of systems we have today and even just the models we have today. So these all came about from training on natural language. But natural language is derived information. So I think, I don't know. Don't give me too hard of a time here. I'm gonna riff a little bit on.
Yeah, I know.
All right,
Go for it.
so humans
Mhm.
on the planet have to move around and interact and go collect food and interact with each other, and so language is extremely useful for you and I to be able to point to something and have a word for it.
Mhm.
Not even specifically so much that we can be in a situation where we're looking at the same thing, we can have a word, but more so if you and I have the same word for something, then later I can talk to you and be like, hey, should we go get that thing that's not directly here with us? So that starts to get into like imagination and concepts,
Mhm.
which is one of the big things I think they credit to like humans progressing significantly, like as a species.
And like out competing,
Exactly.
Neanderthals or
Yeah,
whatever
and the other yeah,
primates. Yeah.
exactly. Yeah, Homo sapiens for the win.
We did it.
We did it. So so the thing is there, right? But what's happening there, right? The word or concept, right? The language, we were so tightly coupled to the environment we're in, those objects, etc. So it's almost like the AI systems today are really starting from such a handicapped space. Like they're only getting books fed into them or sources fed into them. They don't have a world where they're interacting. They don't have specific things like, I know this word rock because a rock fell on me or something, or I saw someone else lift a rock. And so in some ways, it's another reason why I'm kind of so impressed of how useful they are, because it's still such a poor setup, like in total,
Right.
like these are things that don't even get to experience the concepts in worlds themselves like we get to do, and yet they've somehow figured out these patterns. All of this is to say, right? I think there might be quite a big gulf between going from coding agents to agents operating in environments really well. There might be like a bigger gap there, because I think fundamentally, even some of the algorithms and techniques, I don't think they'll necessarily take us there.
Yeah, and I mean, I think we touched on this last time, but the LeCun, or what is that guy's
Yeah,
name?
yeah, Jan LeCun.
Jan LeCun, like that's his big thing.
Yeah,
like,
he's really pushing the world models.
and he's like, the LLMs aren't going to go all the way, and they're going to hit a wall, and we need the world models.
Well, and large, to be fair, large language models have captured world model like information for some domains in a shallow way.
Okay.
And I think if they hadn't captured any of it, they would be way less useful to us. But like you could do rollouts with a model. Like you could imagine setting up, probably not in any of these harnesses, maybe not in Cloud Code or whatever, but you can imagine just doing a bunch of API calls in sequence, be like, okay, what would happen next? Okay, and then you call it again, what would happen next? And what would happen next? And then you could just keep doing that. Obviously, you get this massive branching. So and the other thing is, like, you're just relying on it being able to apply things it knows about, because it's not like reasoning from first principles or anything. It's just mostly retrieving the patterns based on the data. So you probably wouldn't even get diverse exploration of futures. Like you and I could riff on crazy things that might happen like tomorrow or the next day, that might be things that these things would never even suggest.
Well, it's also not either or, right? I mean, I'm playing this game called Shards. I think it's at play-shards.com or .net, which is it's like a Magic the Gathering style game for agents. So your agent plays the game, and and the API is for the agent, and then you kind of work with the agent to theory craft and deck build, and it's super fun. And it's kind of a test of your vibe coding skills, because eventually it just becomes about like how much can you push AI to come up with these strategies and eventually build code and systems. So, Dustin's worked a lot on games and studying different kinds of games and using AI to win games or develop like the most effective strategies. And so he's kind of been advising me about, what is my path to Shards world domination, which is my aspiration. Actually, I hit number 1 on the leaderboard today.
Dude, nice job.
I have to say it's mostly because the ranked queue is empty and I'm like winning games against bots that are timing out, but I did hit number 1. But please go and play Shards so I have like more people to play against. Anyway, the point is, I was not doing that well, and I was like falling down on the leaderboard, until Dustin told me, like, you got to have a world model to go with the LLM rather than having the LLM make all the decisions and reason about everything. That if it had access to a world model, it would perform a lot better. And so in this context, building a world model starts with like building a model of like how the game works. So I like built a game engine, like I reverse engineered the engine from the rules and from games that had already been played. So I have my own engine that knows exactly how to enforce the rules and play the game and can simulate games.
AKA world model.
That's a world model.
Yes, that's a world model.
And then we do these Monte Carlo like forward rollouts and simulations and all of this stuff we can simulate the game, we can try different decks and play them, thousands of different times and figure out what's the most effective. But then the LLM has access to these evals when it's in a live game and it's trying to decide what move to take or what card to play. It has um this world model and these heuristics and these tools that it can access to inform its decision that feeds into its general reasoning. And not only is that like way more token efficient, but also it can't reason as effectively as the world model is able to like reveal all of this data and all this information. And so once I did that, then it was like, boom, I just started like destroying everybody in the game. And so it's an example where it's both LLM and world model working hand in hand to do something that either on their own wouldn't be able to do.
Yeah, and I mean, what I'm exploring a lot of stuff now is, and I've just had this kind of theory for a long time that some of the best architectures or agent harnesses that will win, I don't even know if you need an LLM as the core central mechanism driving it,
Mhm.
but instead you have like LLMs as tools, and you have LLMs in like a meta process that helps you craft it. So
Mm.
I had to write like world models by hand in grad school. Oh my God. I mean, just for different tasks. And like, some of these were like toy domains. I did some work on StarCraft, Warcraft a little bit. I got interested in Dungeon Crawl Stone Soup. That was actually, I was just doing that outside my job for a couple of years. It's just, I really thought that it's a really good, Dungeon Crawl Stone Soup and NetHack still, as far as I've checked, unless something's been published recently, unsolved from an AI. And these are
Ah,
brutally hard games for humans. Like humans will play these games for years and not win. And it's like, I don't know, sad and interesting to go on like subreddits for NetHack and Dungeon Crawl Stone Soup. I think Dungeon Crawl Stone Soup is a little easier than NetHack, but anyway, um, Dungeon Crawl Stone Soup, I like painstakingly wrote, yeah, it was like over a couple months, like a 3,000 line kind of symbolic conceptual world model for the game to model like certain things. But that enabled, once I added that to a system, like it could do planning to do like combat and exploration and all these things. And just for just some these are games that actually kind of came out of like terminal games like from like the 80s and 90s.
oh, cool. Like
Now
Zork and that kind of thing? Or,
so Zork is like text based.
right?
These are like, you would literally draw ASCII grids
Oh,
and you're
cool.
like moving in the grid, but it's just ASCII.
Right.
But like in Dungeon Crawl Stone, so one of my papers, we did a analysis of the state space, and I think I even showed you this
Yes,
paper.
I fed that to my agent. I didn't
Yeah,
understand the
yeah.
paper, but my agent did and did amazing work with it. So thank you.
Well, and so the thing is, like, you look at chess and Go, Go has a large number of potential states of the game that it could be in, right? This affects your ability to simulate the future. Like, how much is there to explore of future states in a world,
So
right?
a state of the game would be, for example, the like in chess would be the pieces are in certain positions.
Yes, that's a
right?
single state.
That's a single state.
Yeah, so you start the game, everyone knows how the board looks in chess. You move one piece, you're now in a new state.
So each move by either player changes the state
Yes.
to the next state.
And so there's been a lot of AI work looking at how you even formally analyze environments to say like how complex they are. Like, so in chess, it's, your actions are always deterministic. And there's always like a fixed finite set of actions at any time based on the pieces on the board. But there are games where, and also you can see everything.
Mhm.
So like the reason StarCraft is so much harder
Mhm.
in some ways from just formal properties than like Go or chess is that in StarCraft, you don't see everything. There's the
Right.
fog of war.
Mhm.
And then also, I think that's good. I actually need to revisit it, but some of the combat logic might be dice rolling. And so then you
Right.
get probabilistic action. And so Dungeon Crawl Stone Soup, for example, has these probabilistic actions. Um,
So like poker, for example, would be there's probabilistic, which is like you don't know what cards are going to come out of the deck.
right. But whenever any card, but otherwise it's a good question. Yeah, you don't know what cards are in the deck. You don't know what cards in other people's hands. You can get probability distributions over those. But then whenever you take an action
Mhm.
in poker,
Right.
there's never you never wonder what's going to happen when you take the action. It's always obvious, like what's going to like either you're going to bet a certain amount and then you know the pot is going to be that amount. Like imagine you're playing poker and like you were to bet, but you weren't sure if all of your money was going to go into the pot or more money was going to be taken or less money was going to be taken.
Right. Yeah, I'm just trying to think of a game example with that mechanism, but I guess any game where there's like I mean, I guess like
I get,
D&D
yeah,
style games
yeah,
have that, right?
D&D is a big,
Where
you
two
roll a dice to
people are gonna
see.
fight each other
Yeah.
and there's like dice rolls
Yeah.
and like you literally like you could know the whole state of the game and all the pieces and everything that led up to it, but you literally can't predict with 100% accuracy what's going to happen because you don't know the outcome of the dice roll
Yes,
until it
exactly.
occurs.
Exactly.
Whereas in poker, like it's interesting because in poker, the player, like the deck is shuffled. I guess you could think of it before the deck is shuffled. You have no way of predicting what the deck is going to
Right.
be.
Yes.
Once the deck is shuffled, the players don't know. But as far as the game's perspective, the deck is known, and then everything that happens other than the player decisions is deterministic.
Right. Right. Yeah, exactly. And so the way I've been approaching AI for a long time is whenever you have a problem you want to solve,
Mhm,
you should think about like what is the environment
mhm,
and what are the properties of the environment, and that determines what AI approach you should use to solve
mm,
that. Which
interesting.
which is it's kind of fascinating now because now it's just like, what are you doing? Ask Claude. Just ask Claude what to do, or just I say that kind of jokingly. It's more like, well, you just pass it to an LLM. Like, so even this idea that like agents are all like so many things now are LLM centric, I feel
Right,
like they treat the LLM as like the core deciding thing.
right,
You don't have to do that. Now,
right,
if you don't do that, you're going to lose flexibility, you're going to lose other things, but you may
right.
gain optimality, you may gain like guarantees that you're going to reach a path or not reach us. You're going to avoid bad states and reach good states. And I have a whole spiel about why I love world models so much, because if you have a great world model for whatever you're trying to do, then you can specify things you don't like, hard nose things you absolutely like, you never should harm a human, you should never do these things. And then you have things like you want, like, I want more money. This is kind of abstract, should find a concrete example, but the idea is you can say things you explicitly do not want, you can say things you want that you're trying to get to, and then you could maybe have soft constraints, like I would prefer not to do this, but if you have to do this. And then the amazing thing is, if you have a world model, right, you can do forward search and exploration, and you can see, first of all, is it even possible? Can I even reach my goals without harming someone or losing this much money or whatever it is? Um, Maybe it's not possible. So that's great to know. Rather than like, you don't get that now with like, if you set up like an LLM based agent, like, can you prove that you were not able to find a path to reach your goal? No, you would just run it and like, oh yeah, it's no, we've set this up, it's not gonna, these tool calls won't be called. There's like no, like we're in like a guarantee free AI scene right now. And so, but with other kinds of AI approaches, you get these nice properties and guarantees. And so, and then let's say it is possible to reach the goal, you can get a path and you can see, okay, well, we know we can reach it. Well, so then maybe we should really invest some resources, and we can see like what, maybe it's more expensive. We can reach it, but it's more expensive than we thought, right? Or maybe
Right,
it's easier than we thought, and we should be doing. But like,
right.
that's the kind Like that's the AI world like I come from.
Mm-hmm.
And so but again, this is so much outside, I think, of coding, and like the world is obsessed with code. I mean, I'm obsessed with. I'm not gonna lie, it is amazing. As someone who coded, like what I can do now with these tools is unreal. But I just think I don't think the coding environment generalizes very well at all to a lot of like even games like you're talking about or real world things. So you have to figure out like what is the environment for the agents? What are you trying to achieve? And then there might be a wide spectrum of other AI approaches or ideas you can use rather than just like going too hard on the large language models.
Yeah, I mean, I think maybe where my mind goes with coding is first something simpler, like before you get to a world model, just thinking about interleaving determinism and non-determinism. So, for example, like let's say you're vibe coding something, and you break it up into a series of tasks or slices or tickets, and for each ticket, you want it to pass through certain gates before it's considered done, right? So, for example, you want it to the LLM builds the code, and then you want to make sure it passes all of your tests, and you want to make sure that the linter is happy and the formatter is happy, and whatever battery of things you want to throw at it. Now you could put in like Claude.md. You could say, hey, whenever you're done with code, run the tests and do that before committing, right?
Yeah.
And the thing is, like, some of the time it's not going to do it. And you're going to be like, hey, it's in your Claude.md. What are you doing? You're supposed to do your thing. And then it's going to say, oh, I'm sorry. I was supposed to
Have
do it.
have you heard this hack? This is the funniest hack I've heard for this, which is so funny, which is people put in their, I think whenever they start a new session, they put whenever you're done with something, I want you to respond to me and say, what is next, master? Or some funny phrase, right? And you in the beginning of this, you put that in first, and then as it's working, it comes back to you. It's like, okay, and what is next for me to do, master? What is and then when it stops saying that, you've reached the real context window limit. Not the limit for what they advertise, but
Right.
you know that the model is no longer following everything as well as it was before. It's almost like a canary in a coal mine thing.
That's really interesting. Yeah.
Also funny.
Yeah, no, it is funny. Yeah, because a lot of people, a lot of times you get worse performance the more the context window fills up,
Yeah.
or things that were at the beginning of the context window kind of like fall out of the direct attention. And um, but it's like there are certain things when you're building something where you don't want, like, most of the time is not good enough. You want to know that this occurred no matter what, right?
Right.
So, and I don't want to have to check it, and I don't want to have to correct the AI, and I don't want to have to, so instead of putting that gate in the prompt, if, for example, the harness enforced it or some
Yeah.
other workflow enforced it, where it's simply not moving to the next step until some code that is not an LLM decided you're allowed to go to the next thing, right? And so that's some mixture of the LLM is there for really the things that deterministic code can't do. Like if you can do it deterministically, you probably should.
Yeah.
It's like,
Yeah, exactly. Exactly.
like LLM's
Yeah.
the last resort.
Right.
Like when no other technique of like engineering, computer science can do it, then you've got your LLM. It's
Yeah.
general reasoning. It's like magical language machine. But otherwise, like never entrust the LLM to do it because you got to babysit it and you got to like massage it. And sometimes it's going to work and sometimes it isn't. And, I mean, in a way, like the entire LLM stack is a series of correcting it over and over again.
Yep.
Whether it's the reinforcement learning, whether it's the system prompt stuff, whether it's the thing you see in the Claude code harness where there's prompts nudging it. Oh, you usually do this, do it the other way.
Yeah.
Whether it's the end user correcting it and be like, no, that was right. This was like, it's an endless series of getting the thing back on track.
Yeah.
And but there's other things where it's like it either passed the test or it didn't. And that is like, you know, completely there that can be done outside of the LLM. And then when you combine that with AI flows where the LLM is being used for what it is suited for, and then you have these gates that are deterministic and decide. Now, if you generalize that, if you kind of extrapolate that into like what does that look like in a world model, I'm curious if you would consider something like formal verification of software. Are you building a world model if you think of the software as a world, or if you think of the spec as a world, or if you think of a series of like security um, claims or something where it's like you are kind of you're thinking of it as like an abstract space, and then you're able to analyze like how you're moving within that space. And maybe there's some kind of analogy there. I don't know.
Yeah, well, no. I definitely think you're onto. I mean, coding is partly a discovery process, actually, because if you, so I think in terms of goals, action states, and and then if you have goals, actually, it's all just state and actions. Some states are highly desirable; those are your goals, and then the states themselves are instances, like, yeah, in some way they're an instance of the world at some like point in time.
Mhm,
If And we could get in, there's like all these weird temporal things. It doesn't have to be a single moment in time, whatever. um but you basically have these. So if you have states, you have a world, you have an environment,
mhm,
and actions are how you transition between, so I would say, apply that lens to coding. Okay, so then what do I see, right? Well, in a lot of ways, it also depends on the level of abstraction you're talking about. So if you're just trying to produce software,
mhm,
then you want to be in a state where that software like exists, and maybe also there's a bunch of like checks you could, like security checks or other things, or it could be like test pass. So you have a lot of like, if whenever you do a state action, when actually what and this is why it's kind of an art, even in in computer science and like AI and also like world models and all this stuff, because the real world or the real environment, even if it is a coding, if it's the real world like Earth, or it's a coding environment,
mhm,
it is um the world itself, that where things actually happen, is usually so complex, you never can fully model that.
mhm,
So
mhm,
what do? You make abstractions. So
mhm,
then you decide how to, like, so then your states are really abstract representations of states. Um
mhm,
and like humans do this effortlessly all the time. Like what are you? Are you a collection of atoms? Are you a collection of muscles and bones? Are you a single human? Like, those are very different levels of abstraction that are useful and not useful for different things. So you have the same thing whenever you apply this. So you could think of your state, you could actually think of your state as all your, let's say you write tests first. You write all your tests. You know the software well enough in the beginning that all these tests have to pass for the software you're making. The state could be whether or not the tests have passed. And so
mhm.
now your goal is the state where all of those tests pass.
Now, what about like the software itself has could be thought of as a series of state transitions.
The software itself.
Yeah, so like for example, let's say you're writing you're writing some code and you wanted it to be the case that um some kind of special data if it's ever like persisted is always encrypted under like that there's no state in the system or transition where you can end up in a situation where the software wrote this data without it being encrypted first.
Oh, interesting. So yeah, it's so I think so it sounds like you're talking about the state of, like, the states in which the software is operating
Like,
itself.
think about it like the software as a Turing machine.
Yes. Yeah. Okay.
And you're trying to like a lot of times formal verification is saying like this software can't end up in this
right.
state,
Right. Yeah.
right? And that might prove a certain security claim or for some
Yeah.
reason.
Yeah.
So isn't the software,
Well, I mean,
isn't the Turing machine a world? Because it has states, it has transitions between those states.
Yeah. Yes. Yeah. 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 I mean, it's like, you know, finite state automata. Like you could actually, it was one of my favorite classes as an undergrad, like computational theory, and like we had to do all these like graphs. Anyway, is I really like that class. But you're exactly right. I mean, all software is, maybe I haven't gone deep on quantum. I don't know if quantum software is any different, but yes, it is literally states. But usually, again, like the abstraction, like that's why it's so nice to program in languages like higher level languages rather than like assembly, or just, you know, x86 or whatever it is. I did write a compiler once. It's a good thing to do once in your life, is write a compiler.
I have yet to do that.
But like in some ways, like that's so, especially with any kind of modern software, like that's massive, that state. And so you have these tools that help you like, and make sure, for example, it's not writing data to somewhere it should never write or things like that. So yeah, you absolutely, I was actually thinking more one level up. So the software itself is a state machine. Might be very, very complicated state machine. And then but then you could think about, like, imagine your computer before the software exists, and your computer in the middle of this, like the software's being built, like it's halfway built, and then there's your computer, like what your files look like when the software is done.
That's its own series of states.
That's like another level,
Right.
that, like, yeah, that's a series of states. Exactly.
At a higher level of abstraction.
Exactly.
Yeah.
Or just about different things.
About different things.
Yeah.
Makes sense.
So, and I guess, you know, in some ways, but that, I feel like with a lot of software is you don't fully know what you want.
Mhm.
And literally that's because if you fully knew what you wanted, you would have the like what you want is the software. So if you fully knew what you wanted, the software would already exist in a way. Like maybe it exists in your mind, but I think if you're being honest with yourself, like you have some features you want, you have some behavior that you want, but you don't know in your mind like how all the code interacts with all the other pieces of code, and even what pieces are maybe needed, or all this. And especially like if you're gonna import a library, you for sure don't know. If you import an external library, you do not know what you want, like ultimately. And like I you know, I'm being a little, I don't know, facetious here or something, but the point is that it is, you know, a process of discovery, I think. Like, because and that's why with coding, you need so much iteration, and that's why Git is so useful, because you sometimes need to backtrack.
Yeah, absolutely. And you kind of, you know, that's part of that inductive process we were talking about, you know, where you can't just, certain things you can't reason purely from first principles. It's too complicated.
Right.
There's too many unknowns.
Or the space is just too big.
Or the space is too big. So you just have to put something out there and then see, and then look at it and respond to it and see how it interacts with this environment and kind of iterate that way.
Yeah.
Which is extremely powerful. And knowing when to use one form of reasoning versus another, or like we're talking about, in a way it kind of can map onto, you know, are you using a deterministic process or non-deterministic? And it's really not an either or. It's like sort of figuring out how to combine these things into the optimal blend.
Yeah.
You know, but it is an interesting question of like, how much, like you were talking about, like the language models only have access to language, right?
Yeah. Some are multimodal. I mean, they've been trained on like images and things like that. So,
right.
But largely, yeah.
Right. Or
it still kind of holds. I mean, even the images are derived.
That's what I was thinking. Like you can think of an image. Well, I mean, that kind of goes to my point, which is kind of like you start to get, so like with the images or the audio, it is expressed in bytes, and bytes are words, or like, a language. And so we're turning the sensory phenomenological world of our experience, um, when we capture it as data, as quantized data. It's not quantized. I mean, I guess on the quantum level it's quantized, but it's like we can experience light as a particle or as a wave. As a wave, it's not quantized, it's continuous.
Yeah.
Like, we quantize it with sensors and instruments. So then we take the picture and then we divide it into bits, or we take the audio and we divide it into bits. And then that's what we give the LLM. So in a way, we've turned it into language. But then you got into the mystery of language, which is like, how is it that the world can be turned into language to begin with?
Yeah.
The sayability of the world. Like, this was something of interest to certain philosophers like Walter Benjamin and Giorgio Agamben, and mystical theories of language, which is like, was language the thing that was created before everything else? Because if language is sort of the hidden part of the being of all things, and that means everything can be turned into language, and language is sort of at the root.
But a question for you here, right? Is all language relative?
Right. That is a related question.
Because in some ways, I mean, it's gets. I spent a lot of time thinking about like embedding models, and and even just like vector representations. So in those, you're kind of predefining a space. So they're not it's not like two vectors are related to one another the way that like a lot of symbolic, like the way you would do like symbolic languages, or like triples, if you're familiar with like subject object predicate triples, which is a very common way to encode kind of like knowledge bases, or
Hmm.
symbolic, or like fact. There's a lot of semantic web work on like trying to just encode, and triples work really good. It's like,
Hmm.
yeah, subject object predicate. Dustin is wearing a shirt, right? That's three things. So you basically have like many facts, and then you want to do reasoning or all this stuff. So, and so and then you can have like relations. Basically, what is subject, object, the predicate is the relation, so it's purely relational.
Mm-hmm. It links the subject and the object.
It links the subject and the object. In vector systems, it seems you don't have that. Actually, what you have is it's relative to the space.
Mm-hmm.
But you predefine the space. But obviously, there's not like a single space. Otherwise, why would anyone have ever tried to make another embedding model? There are many embedding models on many of these leaderboards. They're good for certain things. So it's almost like you freeze the space. So I almost feel like reality, or like language, like, is it all relative? Like,
Yeah, it's a great question, right? So, and it kind
and
of
so if language existed before, or if language is like what came before everything, like I wonder if language can only exist because it's all relative.
no, this exactly gets to the heart of the matter, which is, I think the more, so one way to think about language is as this symbolic pointer. It's just a sign. We say this is a chair, and we could use any sound to point to what we mean by chair.
Yeah.
We could call the chair a table, and we call the table a chair. It doesn't really matter.
Right.
We just need distinct sounds to point to things. And that's purely relational, right? It's not like the chair is transcendentally that sound means chair.
Right.
Right. And so like Walter Benjamin talks about this, where he says there's pure language, which is the language of that Adam had in the Garden of Eden. So when Adam was giving the names to things, those were the secret names of those things, and the
Mhm.
word and the thing were the same thing.
That's
And
interesting.
basically, the Tower of Babel paradigm is when language got fragmented and kind of put into this relative space. But that there's this other form of language that is pure where they become the same.
You think Adam was like using vector embeddings and we were just using
Might have been an AI. I don't
Might have
know,
been an AI.
but the Adam
Yeah, have you
AI.
seen Battlestar Galactica at the very
Oh
end?
yeah. Spoiler alert.
Yeah, yeah.
God, talk about one of the worst endings ever. Don't get me
Not a fan?
started.
Not a
Oh
fan?
man. I really wanted it to end differently, but the but yeah, like this, and I think a few examples of that that are interesting, which is that, like, let's say when you think about a sad note in music, like, would a Martian find that sad? Like, is that something we just learn? Like, there's this sad sound and there's like a happy sound.
Hmm.
Or think about someone like crying out or an animal crying out, right? It's like there's this sound and everybody knows what it means. Like even the animals know what it
Yeah.
means. And so there's a coincidence between the sound and the thing where they merge into one. Or a more
Yeah, I
kind
mean,
of
where does you and your experience of the sound differ from the sound itself? I mean, this gets into some stuff about yoga and like the apparent distinction between the seer, sight, and seen. Like it is just an illusion that it's all just one big illusion. I mean, the word Maya, like one big illusion that you are different than the scenery, and even you are different than the process of seeing.
Mhm.
Um,
Yeah, or the like the like a mantra like Om or something like that is it's not it's ostensibly not a reference or a pointer. It is the thing or the saying it, like the person, the sound, and like all of reality merge into one thing that aren't distinct, and the seer, the seen, and all of it collapses into one.
yeah, because it's, from a consciousness perspective, like that's the ego, right? Like you feel separate from, I feel I am this person, I am Dustin and I'm here, and but like why am I experiencing reality from behind these eyes and ears and not behind yours or somewhere else? And so like and like of course if you get into low levels of abstraction like atoms or quantum, like it really starts to break down. Like maybe there's an electromagnetic field or something that like
Mhm.
seems to be a barrier, but um so I like that gets into like the sound, right? Like where do you really end? Like you're experiencing this sound. It just makes me wonder if there is, yeah, some innateness to it because you are not actually that different.
Mhm.
Or sorry, I should say you're not really that separate
Mhm.
from the sound or other things
Mhm.
necessarily.
Right, and there's I mean, I think the, when we name something so, like, from Heidegger's point of view, language is, uh can be used to unconceal the being of things. Because language, it's not just a label, it's also how we come to, make something intelligible to us, is through putting it into words.
But is you think is words creating that separation?
Well, the from Heidegger's perspective, language is the way we get access to the inner reality of things. It's actually the bridge between us and the thing. It's what
Hmm.
erases the separateness and gives us access to what it is.
Interesting.
So like when we think about, what is a table and then we start interrogating it with language, we don't just call it table, but then we say, well, a table is a flat thing that we, put things on top of. And they typically come in this form and they have this structure. Those are words. And every time we use the hermeneutic interpretive process of applying words to our wordless experience, it changes our relationship with that thing, where we kind of get into its being, like not just how it feels on its surface, but like what is it? And arguably that question of what is it, like what is its being, is something that can only be experienced with language.
Would you say that it's not also beyond language? Like, because in some ways, you know, if you've ever tried to build your own to-do app, which I'm like, or you've ever tried to categorize anything, you quickly run into like all these gnarly edge cases. Like the famous debate, what is a hot dog? Or what is a sandwich? Is it a hot dog or a sandwich? Or is it?
I've heard this debate.
Oh, I mean, there's just a lot of things that have been.
Oh, because like a hot dog, you have like bread or like
Is a hot dog a
meat
sandwich?
in between?
Yeah.
So it's like a sandwich.
Yeah.
Okay.
But
like it's sort of like
like what is a
line.
grilled cheese
Like when you
versus a melt? That's a big internet debate.
I see. Got it.
I think a grilled cheese is technically cheese and bread, but a melt is anything else added to it. But my bigger point is that I guess if you're not talking about like categorizing things, like if you're just talking about like any specific single thing,
right,
maybe this is not as much of an issue. But so much of like, why do some cultures have words that other cultures don't? And I feel like, at least the way I've thought about it myself, is that it's useful to distinguish things that other people may not even bother distinguishing. I have a really funny example of this. So in Farsi, there's 2 words for fart, and they're very different. And like, I don't know why that is, but maybe they felt the need at some point to distinguish between, you know.
I'm not going to try to like infer what that means about like cultural, you know, it's like Eskimos have 100 names for snow.
Yeah,
like,
yeah.
Some language has 100 names for farting. It's like, well, I guess they need to think about their diet or something.
Yeah.
But yeah, I mean, I think
but you know what I mean about this,
yes.
like why do you decide to name some things and not name others? Or why do you even decide? Like, it almost feels like you need to carve that out from other things to be able to even talk about it. So yeah, but you'll always, maybe there's just 2 different things going on here, which is, one is like kind of categorizing and organizing knowledge, in which case like it's very hard to find a consistent language that doesn't have like any like, you can never find something that has an exception for that thing. Like people have made chairs that maybe it's a chair, maybe it's not a chair. It's like hard to know if you define it. But without words, like, can you even do science without words or language? You know what I mean?
So no.
I mean, science loves to invent words and names.
I mean, science needs a clear and distinct idea. It needs measurements. It needs data, right? And all those things are essentially linguistic. But it's also like, it is part of how we shape and create reality by naming things. So yeah, the Eskimos have 100 names for different types of snow, and that is creating cultural linguistic infrastructure so they can name all those varieties of snow and work with them and interact with them and reason about them and build solutions or problematize them, because they've named all those nuances, where if you haven't given those names to those things, you're not able to work with it as effectively. So all those nuances already existed. It's not like the naming of it created it from nothing. But once you give it a name, it comes within like human power.
Because can you think about something you can't name? Not really.
Not really.
And you've been building this into your like meta cognition flow.
Yeah.
I mean,
Yeah, I think this is one of the most powerful tools we have in AI is to be able to name things
and name
and
things that were not previously named necessarily.
name the unnamed, right? It's also one of the most powerful tools we have in human relationships. So the things that go unnamed, we deal with alone and we feel them and they become a form of tension or anxiety or repression. Eh,
It's like that with secrets. I
right.
mean, I've gone through a process where, I have like shared certain secrets that for whatever reason brought me a lot of like shame
Mhm.
or something. I mean, I'm a human being, right?
Everybody's got
Everyone's
that.
got that.
Yeah.
But man, the freedom that I've felt from sharing that or expressing it or naming it
Right.
is unreal. And just to hammer home your point, I think that
Yeah, I mean, that's I think one of the core insights of psychoanalysis is just the power to name the things that especially the things that we don't want to name or that are repressed, and those
yeah,
things eat away at us and they affect us. Or in a relationship, if, there's some kinda dynamic or something unhealthy in the relationship and there's a pattern that's on repeat, but then as soon as you name it, then you can shift it. You're in a frame, and then when you name the frame, you step outside of the frame, and then that gives you the power to choose the frame. And so the same thing happens in vibe coding where, like, let's say you're coding and, um, there's, you keep running into an issue where, for example, like, you're trying to match a Figma design to code and it keeps not working and you keep getting more frustrated and you keep trying this thing that thing and none of it's working and you're spending hours and hours trying to make it work.
yeah, I've been there.
Me too. But then when you name it, like when you stop dealing it with when you stop trying to fix it by yourself and you bring the AI into the conversation about it, so this is where you go up a metacognitive layer where instead of just trying to solve the problem, you start talking about the process of trying to solve the problem with the AI. Then you're going up a layer. And then you bring the AI into the problem and you talk about the limitations the AI has. You say, look, LLMs have this limitation where they're not able to see the design. They don't have eyes yet in the way
Yeah,
we need them to, or they can
yeah.
see the CSS or the structure or like a screenshot
Mhm.
but they it almost seems like they're like a painter trying to paint in the dark, and they'll, like, give you a front end that's obviously ugly and broken and be like, "Hey, isn't this great?" And it's like, "Did you even, like, look at this?" But it's like, again, the LLM's always innocent, right? If there's a
Yeah, yeah.
problem
It's all drive data. It's never actually built or, experienced. Yeah, yeah.
yeah, it's not because it's like, doesn't want to be helpful.
Right,
It's
right.
because this is and so once you and the LLMs, like, they what blows my mind is no matter how meta I get in the conversation, they're always able they immediately pick up on it and can talk about they can reflect on their own limitations, or they can reflect on the process you're using to code with them and give you effective insights. But actually even more powerful is, like, when, um, when I ask the AI, like, let's say like the code is not working and I'm stuck, whether it's Figma or whatever else, there's a million ways that can happen. And then having like asking the AI to name the unnamed, like saying, we're going to stop, just reflect on what's working, what isn't working. And what do you think, what do you think has gone unnamed? And then it will start to identify these subtle issues with how you're working together, the working relationship, right?
Yeah,
And this is no different than like effectively working with other people.
yeah.
Like imagine an engineering manager that never had a conversation with somebody they're managing and said, "Hey, why don't you give me feedback what's going well, what isn't going well, how do you feel? That's an invitation by the manager for that person to name the unnamed, to bring into the dynamic in the conversation. Like, we haven't actually talked about yet, like, what isn't working. Like, let's bring that into language. Let's bring that into the conversation so we can deal with it, so we can work with it. So this is this, and then when we're creating things, to go back, this is like the last point, to go back to discovery versus invention.
Yeah.
When Euclid names the triangle, or when we have a design or a vision or something we're trying to create, and we type it in, and we write things, and we start talking about it and telling its story, that's how we bring it into the world. That's how the creative process works. We start with a vision of a form or something that already exists in some kind of other level of reality. And then we name it, and we use language to bring it into the material world.
I mean, coding is a lot of like turning thoughts into reality. Like
Exactly.
imagining something in your head and then making it real. Um, the other thing that just came to mind with everything you're saying is I think that it does kind of all come down to context and context engineering, but I think that people don't appreciate the scale of the context space of possibilities. Like, first of all, whenever you talk about anything, there is the level of abstraction you're talking about it. And there's often many levels of abstraction you can talk about it. This is, it's faster to talk about things at a higher level of abstraction, but the higher levels of abstraction have they're lossy, right? You lose some distinction.
Mhm.
And so the thing is that, and the other thing is that there is the context of the entities. There's the context of the model you're working with, how it was trained, what data it has seen, what data it has not seen. There is you, like what you know about, what you do not know about. I mean, in some ways, like that's all still context. And I feel like there's a great analogy for LLMs here. Um, I don't. Maybe someone else came up with this. I'm kind of proud of this. LLMs are like genies in the movies. You wish for something, but your wish is always underspecified, so that it is able to be fulfilled in a way that is true, but not what you wanted at all.
Right.
And like I feel like that is always true. Like any request, no matter how well you define it, that you could always, it might get harder and harder and harder, but there's always something that could exist that kind of breaks those rules.
Mhm.
And so I think in some ways, like context engineering is like an infinitely deep problem.
Absolutely. Yeah. I mean, I think it's mind blowing. Like, all these things we learn about in terms of how AI works, there are like analogies back to just life,
Yeah.
you know?
Yeah. Are we LLMs?
Probably.
Probably.
um, or like I like to think about how like humans can be prompt injected, not just AIs,
Yeah. Oh my God.
or there's all these things where it's like you can start thinking of things in terms of like, oh, that dropped out my context window,
Yeah.
like that's why I'm
Yep.
not, able to reason about it effectively, or
Also, isn't it's so much nicer? Like, I remember, I don't know, like, a couple of growing up in school and stuff, there was all this emphasis placed on like whether you're smart or dumb.
sure.
But I feel like now that's so much of a deeper, richer discussion because it's like, dude, that's out of my context window. Or like I didn't have like this is like I don't have enough context or all this other stuff. It's like not so simple anymore. And so we get to be more fine-grained and productive and understanding and.
Yeah, I think in a lot of ways AI is not just an exploration of artificial intelligence, but it's also helping us understand human intelligence in the process, and is a way of not just replacing human intelligence but amplifying it. And as we
Yeah.
learn more about the similarities and the differences between these two types of intelligence. We're going to learn about how they most effectively can work together and kind of complement each other's limitations and differences to overcome both and to create things that wouldn't be possible with just a human or just an AI.
I'm just excited. I think everyone's relationships with themselves and other people are gonna get better.
I agree.
And I just so, I grew up, around people that often got stressed or had other like, yeah, I mean, if you look back in history, like, I mean, all of our literature, so much is, we've like learned so much about, I think, how to be with ourselves and be with each other that's now compressed and so accessible. And so, and really, like, how much of your, they say happiness is other people. It's like you can have all the money in the world, but if you don't have like close relationships, it's worthless. And I'm so excited because I feel like having better, healthier relationships is something this is already unlocking for people. I mean, even myself, like, because something is going on with me that's unnamed, and I work with AI, or between me and another person, I work with AI to figure it out. And then I'm free of that. I'm like not anyway, it's just amazing. I'm just like so looking forward to
Oh yeah. I mean, being able, and it's like, everybody wants somebody who will just listen non-judgmentally,
yes, yes.
whatever it is you want to say,
Infinite patience.
infinite patience. You can go on and on and on. And it's never going to be like, all right, I'm sick of hearing about this. Or can we talk about me now? Isn't it great how the AI never says that? It's never like, enough about you. What about me?
Right, right.
But it's like that is an important resource for people to have that and to be able to explore their inner life and their own mind and their own thinking in a is but the only way that is truly going to be possible is with private sovereign fiduciary local AI
Yes, absolutely.
where the conversation is just between you and the AI. No one else has the data, no one else is surveilling it. As long as there's that feeling that something else is watching, you're never going to be able to get to that same level of intimacy and confidentiality where you can really disclose the things that are the hardest to talk about.
And the thing about all of this that just almost seems like silly is, dude, we're all here having a human experience on this planet, and yet so many things that feel like they're just a natural part of being human are like taboos or like looked down upon, or they're just like, but yet everyone is like a real simple example, right, is just like how nudity is handled in certain like cultures in certain places in the world. It's like a forbidden or even like sinful thing or something. But like,
Right.
dude, when you take a shower, you're naked, like you're nude,
What?
like I mean,
I take a
unless
shower with a
unless
bathing suit.
but it's just like it's I feel like it's almost like elevating our relationship with ourselves as like we're understanding our like humanity better, and just maybe moving beyond. Yeah, I don't know, maybe I'm not articulating well, but it feels like we're just getting major upgrades, like major
Yeah, I mean, I
upgrades.
think it all goes to this theme of empowerment. I mean, I think people have been made to feel ashamed of themselves or their sexuality or their basic nature or essence is bad or
Yeah,
sinful, and that is used to have power over people. Because if you feel ashamed and you feel unworthy, you're way more susceptible to being controlled or manipulated or, oh, I'm so sorry, I'll do whatever you want because I'm bad,
yeah,
right? And so that is deeply ingrained into human psychology. And I think it's one of the biggest sources of disempowerment, of individual disempowerment, that people feel unworthy at a deep, deep level feel unworthy, and we have all this power to access if we believe in it and we believe in ourselves and we're willing to name it and to access it and to go for it. But
I,
as long as we feel like I'm bad and I don't deserve it and I shouldn't access it, like we literally unconsciously deny ourselves access to the power that we have.
yeah, we're holding ourselves back, and yeah,
So I think AI has this dual potential where it can literally enslave everyone and we'll lose all of our power. And it will be based upon that same lie that we're fundamentally bad. It will be you can't be trusted with AI because it's too dangerous. And we need to put the guardrails on because humans are bad and humans are dangerous. And if we give them knowledge, they're going to use it to make a bioweapon or they're going to use it to do something bad. So we have to spy on all of your AI conversations, and you're only allowed to use the government sanctioned AI. And that leads to a world where we have no individual freedom, no free thought. And eventually, essentially, we just become machines and we have chips in the brain. And why leave human nature up to chance at all? Just control everybody top down, boom. And then we have no power, no freedom. And that's the direction I think a lot of people, the people who hate AI or are resisting I think either consciously or unconsciously, that is the future that they're worried about. And in the spirit of like meta hope,
yeah.
of like there's a hopeful vision of AI and there's a hopeful vision of the future that is not that. And it's actually the opposite of that, where the individual is radically empowered, where they're able to resolve these psychological, emotional issues because they have a private language machine that will talk to them about anything with infinite patience. And their people, knowledge is power, intelligence is power. So instead of using AI to make yourself dumber, you use it to make yourself way more intelligent and way more knowledgeable.
I mean, it's really just comes down to, I think, what is really causing kind of negative outcomes and bad outcomes in like, society in general, and like all the things only hurt people hurt people.
Mhm.
And it's really only out of a sense of like ignorance that so many bad, harmful things happen in the world. And this has the ability to
Mhm.
remove ignorance.
Totally. Yeah, I mean, I think, you know, from a more ancient Greek perspective or like the perspective of Plato and Aristotle, the more knowledge and intelligence you have, the more wise you become. Because the more you really understand about the world and about humanity, like to really have true knowledge of that is to have practical knowledge, to have good judgment, to have insights that are all the ingredients of wisdom. They if somebody wasn't wise, they didn't consider, or at least for Plato, like for Socrates, they weren't considered highly knowledgeable or intelligent, right? But now we kind of think of those things as separate. So separate, we kind of imagine this hyper intelligent AI that's going to kill everyone.
Wait, I'm like, if it's so intelligent, why is it so human?
Right.
It should be like the wisest, most beneficial, like, you know,
exactly. Like, why wouldn't super intelligence also come with super morality or super wisdom
yeah.
if it's actually super intelligent? So there's almost like a nihilism or a life denying belief hidden in this view that hyperintelligence equals I want to kill everyone.
Okay, can we just? I know we've been riffing for a while. I have a very big point I want to push here.
Do it, man.
I think it's over indexing on reinforcement learning. I think that's a major. So if you read Nick Ostrom's like Superintelligence, published like mid 2010s, 2016 or something, if you read all this stuff, right? you like the paperclip maximizer that like you give an AI and it wants to get paperclips, and then you give it the goal of making as many paperclips as possible, and it starts destroying planets to get all the materials and like doesn't care about anything else.
Right.
Okay, even now today, right? Reinforcement learning is used in some ways for part of the training process, but we do not use the AI in an RL way. When you code, you give it a goal, you give it things it should not do, it plans, you review the plan, and then it accomplishes the goal, and you can make sure certain things are not violated, and you can check it, right? That's what you get with planning and goal-based things, which AKA you need for world models. So all of this fear is thinking that the only AI technique to learn behavior is reinforcement learning.
That's interesting.
Like that's why I personally have such a problem with like people think like just open Russell and Norvig 1994, the introduction to artificial intelligence, and look at all the chapters, right? There's a couple chapters on reinforcement learning. That's not the only chapter. So like this idea that the things we're building are limited to these optimization things that will ignore everything else, like it's also a fallacy that like we won't be able to like control them.
Right.
You know, but really, really, everyone is over indexed on reinforcement learning. Like, and that's causing a lot of problems because reinforcement learning, first of all, has like major problems. Reward hacking is a known problem for decades and decades. If you're going to do RL, you like, first of all, it's non-obvious all the time how you describe a reward function. I mean, reward functions are inherently limited because you're just giving a numeric signal. You don't even say what you want. Like the AI doesn't get what you want. It gets, oh, I did this, I get +1. Oh, I did this, I get -1.
Right.
It's like this derived like handicap way. So
sure. Yeah.
I like reinforcement learning to me, it's okay. There's some things where it really does work well.
Right.
But that's like only under very specific circumstances where RL really is the best thing. You want to get to world models and planning over world models where you can have soft and hard constraints and goals. Dude, that is the future that like liberates us. Because then it's like, okay, all the things you don't want, just tell it you don't want it. And if it's superhuman, it can, and maybe it's not possible to get what you want and avoid what you don't want. Well, then you can explore that, right? But this idea that like AI is reinforcement, like, oh my God, dude, just please go read some other AI work. We are not, it's not reinforcement learning or nothing.
Wow. Yeah, that's super interesting.
Thanks for letting me rant there a little bit.
No, I love your rants. They're fantastic. So yeah, I mean, I think, you know, these are all reasons to really be focused on the open space of possibility for AI in the future. It's not set in stone. There's all these different aspects to it. Like what we think of AI as today as only LLMs, like is probably going to have nothing to do with the way it works in 10 years from now. And, you know, it may be kind of what Dustin is describing, where the world model is more important and we don't rely on reinforcement learning as much. But it's not set in stone, and the future is being created right now. So let's create that positive future. Let's have hope. Let's have excitement about what we can do with AI, where we can end up. And that's what this podcast is about. And, you know, this is going to be this mixture between talking about reinforcement learning and Monte Carlo rollouts and all this like hardcore computer science and cryptography and technical things. And
also thrown in with some yoga, meditation, like philosophy. And I think those, because of AI, especially those things are all kind of collapsing and becoming more important.
Exactly. So join us on this exploration of the interweaving of these topics. We think there's really something important and interesting here, and really helps us kind of figure out how we're going to use these things in a positive way that are really going to help transform our lives and overcome some of the problems we've been dealing with politically and otherwise.
And if you have some comments or questions, please drop them in the chat wherever you see this video, and we'll talk about it next time.
Yeah.
So,
take care, everyone.
Take care.